Hello students, today's video is focusing on conservation of energy. It's one of the important principles in physics. This principle or this law was developed by Einstein after he did his work on E equals to mc squared. So basically what it says is that if you have energy, you cannot add to the bulk of energy that is present, and you cannot also destroy energy. Basically, what that means is that energy cannot be created nor be destroyed. However, you can change energy from one form to another form. So that is the law of conservation of energy developed by Sir Albert Einstein. Okay, what does this law mean? Basically, it means two things. You have an input energy and an output energy. The input energy is the total amount of energy that goes into an energy converter. What's an energy converter? An energy converter is basically any device or appliances that make use of energy, that relies on energy to make it work. It could be a washing machine, it could be computer, it could be a car, whatever. It's an energy converter. So the energy that you put in should be equal to the energy that you get out of the energy converter. But when the energy is out of the energy converter, it is changed into different forms. But if you add all the different forms, the total amount of energy, you should get the same amount of energy just as you put in. So that is what this law talks about. Remember, energy can be stored in many ways. For example, when you have a rubber band and it's stretched, the elastic potential energy store increases. When an object is lifted up, you increase the gravitational potential energy. Okay, brilliant. So now, let's take a look at a pendulum. A pendulum swings, it moves to and fro. Basically, what happens is that you have a kinetic energy changing continuously until you get potential energy. Now, at the ends where the bulb is, where the bulb turns, at this point, you have the maximum gravitational potential energy, this part. You have the maximum gravitational potential energy. So here, GPE is maximum. It's max. Okay. When it gets to this point as well, GPE is max. GPE is max. It's maximum. Okay. Now, the energy will start changing when it's moving this way. You move this way. Then what happens is that GPE is decreasing. So GPE decreases. And when GPE decreases, then you are increasing the kinetic energy, sorry. So GPE decreases. Okay. So here GPE decreases because it's changing. It's if you look at the height, see it's going down. It's heading towards. So here, kinetic energy is maximum. Here, kinetic energy is maximum. Kinetic energy is max. Okay. So before, When kinetic energy is maximum, then it means GPE is 0. So here, that's the bottomless part of the pendulum. At this point, GPE is 0. It's lost the height, basically. Okay, there's no height. And anytime there's no height, the gravitational potential energy will be 0. Okay, so here you could see that the energy is changing. However, the energy that you put in should be equal to the energy that comes out of it, because of the law of conservation of energy. Because energy cannot be created nor be destroyed. So if the bulb pendulum starts from here, there's no way the pendulum can swing and gets up here, because you need energy to make it move higher than what it was. But because energy cannot be created, there's no way the pendulum will swing up here. It's gonna go to this point, which is at the same level, then swing back. However, the pendulum will slow down because it's gonna lose the energy to the surroundings because of the collision of the pendulum and the air particles around. So there will be loss of energy. Basically, energy will be dissipated to the surroundings, okay? Right, so we're gonna move on to the next slide, which talks about a bungee jumping. So when you bungee jump, it's an elastic material. You lose gravitational potential energy. When you move up, you gain gravitational potential energy. So when you're moving down, you are increasing kinetic energy and reducing gravitational potential energy. So here, if you are moving down, your GPE goes down. There's a loss. There is a loss of GPE. Okay, GPE is lost, so it's going down. Whenever GPE is lost, automatically KE is gained, because they work hand in hand. If you lose GPE, you gain kinetic energy. So GPE is gained. Okay. All right. If it moves up, then the opposite occurs. GPE increases, and KE decreases. So GPE increase and KE decreases. Okay, so please take note of this. It's a very important concept. You might have to apply it most of the time under energy. Okay, so that's how bungee jump, the energy transformation that occurs here. Now, let's move on. Okay, so now we're gonna answer some few questions. First of all, name the 5 energy stores. Describe energy transfers with examples. Describe the conservation of energy. Apply conservation of energy to energy transfers. I'm going to start from the bottom. The last one, applying conservation of energy to energy transfers. So for example, if I have this as, so the energy that goes into, this is energy converter. So the energy that goes in is 100 joules. Remember, the unit for energy is joules. So 100 joules goes in. Then I'm going to expect 100 joules out. Okay. Let's say this is, let's assume this is a light bulb. So light bulb. This is a light bulb. Basically, the energies that will come out will be heat and light. So you get heat or thermal, okay, and then you get light. So let's assume that light bulb normally, the ones that are not efficient, they produce a lot of heat. So let's assume that you get 80 joules here. Okay. And then the one that the light is going to be 20. It cannot be more than 20. Why? Because the energy that was put in was 100. So the total amount of energy that comes out should be 100. Okay. So here, this is the output energies. Is the output energies. And that's the input energies on the other side. Energies. Okay. So that's the input energy. So basically, the law of conservation of energy says that the input energy should be equal to the output energy. There's no way the output energy will be more than the input energy. Okay, that's the law of conservation of energy, because here the energy that goes in has not been destroyed. It went into the light bulb. The light bulb changed the energy, which is the electrical energy, into light and heat. So the energy hasn't been destroyed. And then the amount of energy before is the same as the amount of energy, the total amount of energy after. So that is the law of conservation of energy. Okay, so any energy transformation or energy transfer obey this law, the law of conservation of energy, which says that energy cannot be created nor be destroyed, but it could be changed from one form to another. So in GCS, you might get questions where you've got to explain how energy conservation is occurring here, or the law of conservation of energies. So basically, your input energy should be equal to your output energy. If you're able to prove that, then energy has been conserved. Name the 5 energy stores. Very easy. Very easy. We've done it in previous lessons. Chemical, gravitational potential energy. We have elastic potential energy. We have nuclear energy. These are all energy stores. Okay. Describe energy transfer with examples. Very easy. This one I've done here is an example. So to sum this topic up, the law of conservation of energy, first of all, you should know how to state the law. Energy cannot be created nor be destroyed. However, it could be changed from one form to another. That's the law of conservation of energy. It was Einstein who came up with this law after his extensive work on energies. Another thing that you should know is that input energy should be equal to the output energies. And you will need to use that, especially when you're doing Sankey diagrams and you're also writing out energy transfers. Thank you very much. I'll see you again for another lesson. Bye.